Hey everybody, we're going to be starting on 5.3, proving triangles are congruent using the ASA and AAS properties, which means angle side angle and angle angle side. We talked about yesterday side 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 and side angle side theorems, and today we're just moving on to two new ones, so I hope you're ready. Okay, so we are going to be showing triangles are congruent using the angle side angle theorem and the angle angle side. But first, I want you to know what an included side is. Okay, you only have to write down that very first sentence. Don't worry about this second sentence here. An included side is the common side of two consecutive angles in a polygon. So if you look at this this triangle, side PQ is the included side of angle P and angle Q. So that side that connects those two angles is going to be your included side. So that side that they have in common is also your included side as well. Which leads us into our angle side angle congruence property. It says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles as a whole are congruent. Yesterday we talked about the side angle side congruence, which means we needed the included angle. This one is kind of flipped around where we have angle side angle with the included side this time. All right, so now let's see if we can put this into reality. Determine. You do not have to write this down. Determine if you can use the angle side angle to prove the triangles are congruent. We're going to explain. On this one, you do not have to write a two-column proof. I definitely think two-column proofs would help in your explanation and can do that, but you do not need to do so. Okay, so as we look at these two triangles, all right, notice that we have two angles that are congruent. We also have this side in between them that would also be congruent. Why would that side be congruent? Well, it would be congruent because the reflexive property says they would be congruent. So we're trying to figure out if the angle side angle property applies here, which means that included side needs to be congruent to the other included side of the other triangle. Now, can we prove that? No, we can't. In this property, we cannot do so. If you try, we aren't given enough information to say that that is possible. So no, because the included side of each triangle can't be proven congruent. It cannot be proven congruent based on all of the theorems that we know, the postulates that we know, the definitions that we know. It is not possible for us to say that that side is congruent. So we cannot use the angle side angle property. Okay, because that's what we were looking for. I want you to try this one, see if you can determine based on everything you know, can you use the angle side angle to prove triangle NKL is congruent to triangle LMN? Explain. Again, you do not have to write a two-column proof, but I believe a two-column proof can be used in your explanation, and it would help in your explanation to prove if this is true or not. All right, so now the given information that I know, and I'm going to write this down so you can see, side KL is parallel to side NM. How do I know that? Well, that's given. Okay, so I know that that is true. I also know that KLN is going to be congruent to angle MNL. How do I know that? I know that KLN is going to be congruent to MNL. Looking at those two angles, what type of angles are those? They are alternate interior angles. Okay, so I know that that is true. I also know that NL will be congruent to NL. Why? That's a reflexive property. Okay, so now looking at this, I know that an angle is congruent to an angle on the other triangle. I know the side is congruent on the other triangle. However, I cannot prove that the other two angles are congruent. I cannot prove that angle MLN would be congruent to angle KNL. That's impossible for me to know. In order for me to know that, I would need to know that NK would be parallel to LM. I am missing that piece of information in my given information. I do not know that. So, can I prove ASA? Can I use that to prove it? No, I can't. So ASA can't be used. It can't be applied because other congruent relationships can't be determined. Going down a little to the side there. That's all right though. Okay, so that explanation is my explain there. So that is a correct answer. I hope you are able to find that that is impossible for you to be able to use the ASA based on the information that we were given to start out with. Okay, so it all depends on what information we start out with to see if it is true in the end. All right, so here's another theorem. It is the angle side. It says if two angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. So you need two angles and a non-included side to be true. Okay, two angles and a non-included side to be congruent to two angles and a non-included side of another triangle to make those two triangles congruent. All right? So let's give one a shot here. Okay, you do not need to write this down, but I'm going to use a two-column proof to help me. Please follow along to see if we can prove this is possible. All right, so it says given that JL bisects KLM, angle K is congruent to angle M, we need to prove that these two triangles are congruent. All right, so we know that given our given information, angle K is congruent to angle M. That's given. We also know that JL bisects angle KLM. That is also given. Okay, we know that to be a fact. Okay, so now we know that's true. So looking at these two triangles, remember, try to separate them in your mind. Okay, if you need to separate them to make it easier to look at or to visualize, please do so. We also know that JL is going to be congruent to JL. Why? Because of our reflexive property. We know that's true. Okay, so now we know that JL is congruent to JL. In order for us to use angle side theorem, we need another angle to be congruent. All right, so that angle needs to be Well, it is going to be angle KLJ is going to be congruent to angle MLJ. So KLJ is going to be congruent to MLJ. Why is that going to be congruent? Because of our angle bisector theorem. Okay, we were given that second piece right here, which means we can use that angle bisector theorem in the later on in our two-column proof. Okay, so now that we know two angles and a non-included side of each triangle, we can safely say that triangle JKL will be congruent to triangle JML because of the angle side theorem. Okay, we were just able to prove those two triangles are congruent. Let's try one by yourself. I want you to try this next one like this. Try this problem based on the information that you know. Expand your mind one more time, okay, and try to get the information to fit in with a two-column proof. All right, see what you come up with. All right, we start off with the given information that we know. We know that for a fact, angle X is congruent to angle V. That's given. We also were given angle YZW is congruent to angle YWZ. Also given. The last piece of information, XY is congruent to VY, and that was given. Now we need to come up with our own information, generate our own information based on the given information we know. All right, I'm just going to draw in here. Angle X is going to be congruent to angle V. YZW is going to be congruent to YWZ. Now, we also know that XY is congruent to VY. We want to use the angle side theorem. Okay, so in order for us to know the angle side theorem, we want that XY to be the non-included side. So we need to somehow prove that angle YZX is congruent to YWZ. How can we prove that those two angles are congruent? Well, first off, I'm going to write it down. Angle YZX is going to be congruent to angle YWV because of those are supplementary angles. Okay, those are supplementary angles. If we know that YWZ and YZW are the exact same angle measures, the supplementary angles theorem, or you could also say linear angles theorem, has to prove that these two angles are congruent. They have to be, based on what we know about our linear pairs and our supplementary angles theorem. Okay, so that right there proves that triangle XYZ is congruent to triangle VYW because of our angle side theorem. Okay, that is the information we know. That is angle side angle. That is angle side. You will get your homework tomorrow. Have a great day. Remember, ask me any questions that you are confused about tomorrow. All right, have a good day.